All right, we have another trigonometric substitution integral here. We see that sum of squares, which reminds us that trigonometric substitution is a viable option. Now we're going to use trig sub because regular substitution won't work. Whenever we have a sum or difference of squares, if regular substitution doesn't work, then we're going to go with trig sub. First thing I like to do is factor out that 81 so we can look at our basic integrals that integrate to arc functions, not the more complicated ones. And so we use our magic multiplication by 1 skills here. The 81 can now factor to the front. It's in the denominator, and it's coming through a square root, so it's going to pop out in front as a 9 in the denominator. And so that leaves us with this. And we want to have a single square on the right here, so we'll make that x divided by 9 quantity squared. Now we're good to go. So at trig sub, it's sine, secant, or tangent. Tangent's the most obvious one. When you have a plus, it's always tangent. So x over 9 equals tangent of theta. And then we take our derivative. We'll get 1/9 dx is equal to secant squared of theta d theta. And we're going to make our substitution now. We notice that we have an x squared here, so we isolate x up there. X will be 9 tangent theta, and that's going to be squared. So we have 9 tangent theta, quantity squared. And then the dx, we isolate that dx, we multiply both sides by 9, so we get 9 multiplied by secant squared of theta d theta. Put the d theta on the side. Square root 1 plus tan squared. The whole reason we substituted tangent in is that we can now use an identity and we can combine those two terms into one term in the denominator. We have a 9 that will cancel. We have an 81 that's going to come to the front. So let's see what we have inside this integrand. We have tan squared, secant squared in the numerator. And down below, this 1 plus tan squared, that turns into a secant squared, and the square root of secant squared is secant. Again, there's a little caveat there that the square root of secant squared is only secant if secant is a positive value. We're going to assume that that's the case. Otherwise, they would tell us. They would let us know that there were shenanigans to pay attention to, but they didn't, so we won't. So we end up with tangent squared of theta multiplied by secant of theta. We have a product of tans and secants. Neither of our two basic criteria hold. We don't have secant to an even power. We don't have tangent to an odd power. So then we either use a Pythagorean identity or we go to sines and cosines. And in this case, the Pythagorean identity looks like it might work fine, so let's go ahead and do that. So tangent squared is equal to secant squared minus 1. And let's see, what are we going to use to integrate this? Well, we're going to distribute first, and we're going to see one of our dreaded integrals, the secant cubed. Secant cubed is always a little bit of a bear, minus secant of theta d theta. So we've already done the integral of secant cubed in class a few times. The integral of secant cubed can be done with a power reduction identity, but you're not expected to remember any power reduction identities other than for sine squared or cosine squared. So the way that we typically would integrate this then is using integration by parts. So I'm not going to do that part here. I'll just go grab the antiderivative, but you should know how to integrate secant cubed using integration by parts. So we have the the integral of secant cubed from integration by parts is 1/2 secant theta tangent theta.
Okay, I can go back just a minute, but I think those are in the course. So
Plus 1/2 natural log absolute value of secant plus tangent.
okay.
So we did that again with integration by parts. We've also integrated the secant function quite a bit this semester, and we know that that's going to be the natural log of secant plus tangent. Natural log of the absolute value of secant plus tangent. And we did that by rewriting secant into log form by multiplying the integrand by secant plus tangent over secant plus tangent. Okay, so at any rate, we're there. Now we need our special triangle to get rid of all these thetas and get back to x's. So we're going to put a theta right there in the corner. We are going to look at what our original substitution was. Tangent is x divided by 9. So tangent is opposite over adjacent. So tangent theta is x over 9. We then get our missing side using the Pythagorean identity, Pythagorean theorem. That'll be the square root of x squared plus 81. And let's start filling in the blanks over here. Okay, so we have 1/2. Secant of theta is hypotenuse over adjacent. Tangent of theta is x over 9. And now we're looking at these two, and they are like terms. So we have 1/2 natural log minus natural log. So we're going to end up with minus 1/2 natural log of absolute value. Secant plus tangent, so that's going to be the square root of x squared plus 81 over 9, plus tangent is x ninths plus c. So let's get some simplification going here. We're going to have an x multiplied by square root x squared plus 81 divided by 81 times 2. 81 times 2 is 162. And then here we're going to have 1/2 minus 1/2 natural log. And now they are going to do something clever in many of the books that you look at. And here's what the clever step is. They're first going to combine these two fractions into one fraction. And then they are going to use a log property. Namely, we know that the natural log of a over b is the natural log of a minus the natural log of b. Well, when you do that, the natural log of 9 is a constant. And when we are dealing with integration and we are combining constants, we use the c to represent combinations of constants. So if we have a constant and then we add another constant to it, we're just going to continue to use the c. It's kind of like a recycle bin. And so when we use a log property there and end up with minus 1/2 natural log of 9, that's going to combine with that c out there. And so this will be completely simplified to just the natural log of the numerator. And when we do this subtraction off right there, that's a constant, minus 1/2 times the natural log of 9. That gets combined with the plus c. Good job.